Problem 446. 3 blocks, each having a mass of 1 kilogram, are connected by rigid rods of negligible mass and are supported by a frictionless surface. Forces F1 and F2 of magnitude 5 newtons and 10 newtons respectively are applied to the ends of the blocks. Find the forces acting on block B. Block B is in the middle. The way I'm going to approach this problem is I'm going to first of all find the acceleration of the system and recognize that all the blocks are going to be undergoing the same acceleration. Then taking the mass of block B and multiplying it by the acceleration I found in the first step gives me the net force on net B. I will also have to look at what the net force on block A is in order to get to B. So to start off then, let's look at the system. MA plus MB plus MC. Look at all of that as a system and realize that I have a force F2 of 10 newtons acting on the left side of it, and a smaller force of F1 acting on the right side. And so the acceleration of this system is going to be the total force, which is F1 plus F2, divided by the total mass. Okay, so that boils down to 5 newtons plus 10 newtons, 15 newtons over 3 kilograms. Each one of these masses is 1 kilogram, and that yields a system acceleration of 5 meters per second, which is what each of the masses will individually accelerate at. So now I focus on mass A, and then I will move on to mass B. So for mass A, I have a force from the left of F2, and these rigid rods that separate the two masses MA and MB, this particular one, there will be a force backwards, which I'm going to call B on A. And so the net force on MA, M sub A, is F2 minus FB on A, net force to the right, and that is going to be equal to M sub A times A. Well, I know what M sub A is, I know what A is, and so I can solve for FB on A. So doing so, FB on A is equal to F2 minus MA times A, and so that's going to equal to 10 newtons. Let's label these forces here. This is 10 newtons and this is 5 newtons. Minus M sub A, 1 kilogram, times the acceleration, 5 meters per second. So this is 5 newtons, 10 newtons minus 5 newtons, 10 newtons minus 5 newtons is 5 newtons, and therefore F of B on A is 5 newtons. So now when I move on to mass B, M sub B, it is going to have a force F of A on B. It's a reaction force. I know this is 5 newtons, just equal and opposite in direction to the other one. and in the other direction it's going to have F of C on B. Okay, so I can write a Newton's second law equation for mass B, and that will go m sub b times a, same acceleration as before, is equal to F of A on B minus F of C on B. This is net force to the right. I know what A on B is. I can figure out what F of C on B is. F of C on B is equal to F of A on B minus F of B times A, m sub B times A, and that's equal to 5 newtons. That's what we got before. The magnitude is 5 newtons, and this is minus 1 kilogram times 5 meters per second per second. This is 5 newtons, this is 5 newtons, and that's equal to 0. And so therefore, the two forces that act on B are the force of A on B, which is a 5 Newton force, and a force of C on B, which is, in this case, a 0 Newton force. And I'm ignoring the forces in the vertical direction, concentrating on forces that are in the horizontal direction.